Hi, Year 10. So today we're going to look at another required practical, this time for electrolysis, which is the splitting of things depending on their electrical charge and using two inert electrodes. So first of all, our two learning outcomes for foundation, predicting the products of electrolysis, and secondly, describing how to investigate electrolysis using inert electrodes. And then for the higher tier, they're looking for a little bit more detail. They're looking for how to write those half equations that are occurring, for the reactions that are occurring at the electrodes when we've got an aqueous or molten solution. So again, as always, if you want to look up the information in the Caboodle textbook, you can use your online account, pages 92, 93, supplement your notes to this PowerPoint and my dulcet tones. So, the diagram. Now, you do need to make sure that you've got this clear in your head. And anodes are positive and cathodes are negative. Therefore, the positive ions move to the cathode and the negative ions move to the anode. Now, sometimes when we look at this in industrial applications, the outside casing of my electrode is made of a different material, but let's not worry about that at the moment. We will go into that in a bit more detail in a minute. So here we've got my molten solution, and it could be either molten or aqueous, because remember, ionic compounds only conduct electricity in molten or aqueous state, and that is a fictitious line down the middle, and that fictitious line isn't a semi-permeable membrane, which lots of people get really, in the pressure of exams, start chatting about. It's just there. That's the edge of the draw of those electrostatic forces. So be aware that that line is fictitious. It's just saying everything on this side that's positive will move to here, and everything on this side is to there. So here we are. So the purpose of electrolysis is to split those ionic compounds using electricity to produce useful products, depending on their reactivity. And we do need to be able to relate this to the reactivity series. The electrolysis is used a lot in industry, and it is a multi-million pound or billion pound industry. We use it for all sorts of things that actually, where we're extracting small amounts of copper, aluminium, and when they're not in particularly large quantities, quite quickly. However, it's a very energy intense process. There is a huge cost to it in terms of energy input. So you do need to make sure that your profit it's economically viable. So the method. So you do need to be able to investigate what happens when aqueous or molten solutions are electrolyzed using inert electrodes. And inert just means that they're made of carbon or another unreactive material. Carbon, graphite, okay, either of those will do. You do need to be able to describe the method step by step. And again, this is a common 6 marker on paper 1. So here's your method. What I suggest you do is copy that method down. So first of all, we talk about adding a set solution. If we were working out the yield or the amount of product formed, we'd need to measure that exactly. A solution of salt in a beaker, and we're going to add our inert carbon rods. So you might be thinking, well, we've just used black sticks. Yes, they're your carbon rods, and we're pushing them through the holes into usually in a piece of wood that go through holes so that the rods don't touch, because actually we don't want the rods to be touching each other, because we know that graphite, due to free electrons, is able to conduct electricity. So we don't want to make a circuit with the rods. We want the circuit to be made through the molten and aqueous solution. We're going to attach our crocodile leads to the electrodes, and then we're going to connect the rods and to the power supply. We're going to switch on the power supply. Now, when you've done this in class, you probably had a bulb in your circuit, and the purpose of the bulb isn't just to make the room look pretty. The purpose of the bulb is to show that the electrons are flowing. Okay, so sometimes they ask you, why would you put a bulb in the circuit? Because unless you're daft enough to put your finger in the solution and give yourself a good old shock, you're not going to know. So please be cautious of that little question, that little curveball that they'll throw to you. Why is the bulb there? Check the electrons are flowing. So the additional information that they want you to know is that gas is produced at the positive electrode, which is my anode, which bleaches damp litmus paper because it's chlorine. And if a gas is produced at the negative electrode, it's always hydrogen. And the link below will take you to the online demo. Don't worry, I'll cut and paste that into the show my homework, so you've got it there for prosperity checking. If there's nothing on TikTok to watch, you could just watch a bit of electrolysis. Riveting. So, risk assessment. Safety goggles need to be worn throughout. There is a risk of electrocution. Just think about this. Those solutions aren't nice. And actually, when we've allowed the solution to be electrolyzed for a long time, we actually change the pH of that solution and it can become quite harmful. So we do need to make sure the safety goggles are worn. Any spills need to be cleared up. Also, if you start off with something like copper sulfate, that's not nice if you get it in your eyes. We're talking long-term visual impairment, not fixable by a pair of Ray-Bans. Okay. So, example of a results table. Again, you might be asked to sketch this in the exam. So, they would want you to know what's happening at the negative and positive electrodes. So the negative ion in the solution is chlorine, and the element that would be given off, and you need to be really careful with this because they want you to tell you what the product is. The product won't be the ion. The product will have either gained or lost electrons to become an element. So the chlorine will convert to chlorine, but we need to, for the higher paper, they're going to know, do you know that chlorine doesn't like being on its own? It likes to be in pairs. The same with bromine, the same with iodine. Okay, and the same with sulfate and nitrate. Okay, the oxygen also, all of those are diatomic molecules. So, here's a good example of a nice table that would tell you what is made at the negative and what is made at the positive. And as you'll see, at the negative, we've got copper being made and hydrogen, whereas at the positive, you've got chlorine and oxygen being made. You can simply work that out using your periodic table, and your teacher will show you how to do this when you get back to school. So here we have aluminium. The extraction of aluminium is key, and we know that we basically make aluminium bauxite liquid, and so the aluminium is dissolved in cryolite, and the outside casing of my vessel is my negative electrode, and that negative electrode will begin to break down over time, and so will the positive. Okay, because we've got carbon dioxide gas being released there. So what's happening in this diagram, and you are expected to be able to label the diagram and explain what's happening at each of the electrodes. And these are the half equations that we talked about at the beginning in the learning objective. So each aluminium ion, which is Al3+, gains 3 electrons. We know electrons are E-. So if it's Al3+, we need to add 3 electrons. So all we do is go, right, Al3+, plus 3 electrons equals Al, which is my element. At the positive electrode, okay, we've got oxygen being formed, and the ions, again, we've got O, big O, 2-, which means that we need to gain 4 electrons because there are 2 oxygens. Yeah, because we know that oxygen likes to be in a pair. So we need to gain those 2. Now here's an exam question. An investigation into electrolyte copper sulfate solution was carried out as shown. Okay, so basically this is the same thing, just slightly upside down. Well, it's very upside down. It's not slightly upside down, it's just upside down. What does electrolyte mean? What were the observations? Name the solid formed. Name the gas given off. And how could the sample of gas be collected on the positive electrodes? Take a second to think about those 3 questions for me. Even 4 questions. Take an extra second. Now let's go through the answers, which I've already seemed to have put up. Marvellous. So, electrolyte means a substance that is broken down, that separates, that splits into elements. And these were the observations. Name the solid formed, it's copper, and oxygen is the gas given off. How could a sample of gas be collected at the positive electrode? Put your chest tube over the top of it, okay? But it would need to be full of liquid to start with, okay? If you think about remembering collecting gas over water or counting the bubbles in photosynthesis, it's an inverted test tube that is full of the liquid that's already in the solution. And suggest why the blue colour of the copper sulfate becomes paler during the investigation. So Cu2 plus ions are removed, or there is less Cu2 in the solution at the end. So these are the useful links for this practical. I have put them all in the show my homework notes at the bottom. As always, guys, enjoy. If you've got any questions, drop me an email. All right then, take care. Bye.